Okay. All right. So, all right. All right, focus. All right. A relative maximum is a point at which the function f switches from increasing to decreasing. Just think about what it looks like. If you're increasing and then you switch to decreasing, that's going to cause there to be a maximum point. So if the function is increasing, what do we know about the derivative? Positive. So the derivative has to switch from positive to decreasing with negative. All right. So the opposite of this is true for minimum, right? If we go from, guys, quiet, decreasing to increasing would be negative, positive. Jack and Daniel, quiet. I didn't hear his voice. All right. So it is really important that we really make sure we understand this, because these problems always show up on free response section, and a lot of times also in multiple choice. This is a really big section. And if it is on free response, you will have to justify your answer. When you justify your answer, you have to talk about the derivative. So this piece right here, this is your justification. Justification. And then same here. Okay, that's your justification. What we see right here, this is your definition. All right, so if the problem asks you to find a maximum, you cannot say that the maximum is at 7,4 because the function switches from increasing to decreasing. While it's true, that is the definition of a maximum. So it does not show that you're proving that you found that any way at all. It just shows you know the definition of a maximum. Right? So it doesn't prove that that's actually the case. To prove the case, you have to talk about the derivative. Okay? Same is true for increasing and decreasing. You're just less likely to make that mistake with increasing or decreasing. Here, you have to talk about the derivative when you're finding a relative maximum or minimum. So let's look at a problem that you're going to see here. Find all relative extrema of f of x equals 2x to the third minus 15x squared plus 36x plus 10. Justify your answer. So, Selena, tell me how to find that derivative. Very good. So once we find the derivative, then what do we have to do? Okay, we're going to set this equal to 0, and we are going to factor it. I would factor out the 6 first. You cannot solve it really any other way. So if I would just divide everything by 6, you cannot. If you solved it without factoring, I guess you could use quadratic formula, but yeah, that would not work. Don't do that. Okay. Quadratics, everything needs to be moved to one side. It needs to be factored, or you could use quadratic formula. Okay. What do we got, Thomas? Very good. And so we get x equals 2 and x equals 3. Doesn't work because it gives you a -6 on the end. If you do a negative 6 and a positive 1, when you multiply it back, it's going to be x squared minus 6x plus 1x. Looks like it's going to work until you do this last part. It gives you a minus 6. You need to have a plus 6 right here. That is a very, very, very common mistake. Thomas would never do it, but lesser mathematicians sometimes make that mistake. So on our number line, we're going to put a 2 and a 3. We're going to do just like we were doing yesterday when we were finding increasing and decreasing. I like to do the chart. So this factored is 6 times x minus 2, x minus 3. It's really not that important to put 6 on your chart for this problem because 6 is positive. Because I want to. If you just want to plug back into the original, you can, and into the derivative. But 6x squared minus 30x plus 36 is 6 times x minus 2 times x minus 3. Okay, so let me just back up here a second. So what I want to do is figure out if my derivative is positive or negative. So one option that you have is just to take a number like 0 here, plug it into 6x squared minus 30x plus 36. Then pick a number between 2 and 3. Here's the reason I don't love that. A number between 2 and 3 has to be like 2.5, and you've got to plug it into 6x squared minus 30x plus 36 without a calculator. So to avoid having to do that, so it will still work. You just have to deal with that. So to avoid doing that, all right, everybody's got to stop thinking out loud. Think in your head. All right, so if I factor this, which I basically did here, I divided off the 6 when I was solving that, but I could have factored the 6 out instead. This factors to 6 times x minus 2 times x minus 3. So this is equal to the derivative, right? This is still f prime of x. So if I check each piece of that to see if it's positive or negative, I know 6 is always positive. So technically you could leave it off here, but if that 6 was negative, it would change your answer. So I'd like to include it there. Because it's just 6. It does not have a variable with it, so it's just always 6. Then for x minus 2, if I plug in 0, I'd get a negative. If I plug in 2.5, this is easy now, right? 2.5 minus 2 would give me a positive. And if I plug in 4, I'd still get a positive. And then if I do that with my x minus 3, I'd have 0 would give me a negative. 2.5 would still give me a negative. At 3, it switched to positive here. So the reason I like to do the chart is because it's easier to plug those numbers in. And then all you have to do, this is positive times negative times negative. So if you have an even number of negatives, you're going to get a positive answer. If you have an odd number of negatives, like you do here in the middle, you'll get a negative answer. And then, of course, if they're all positive, you'll just get a positive here. Odd number of negatives is negative. Even number of negatives is positive. And so the
does that all the time. I'm thinking every day. Stand up. The real Slim Shapes.
all right. Quiet. so what I've highlighted here, this is where we find our answers from. All this stuff up here was just work to help us get those answers. And like I said, if you don't like doing the chart, you can just plug into the derivative, which is fine also. But I prefer the chart. So, this problem does not ask, guys, quiet. Okay, this problem does not ask us for increasing and decreasing like we were looking at yesterday. It asks us for maximums and minimums. So, let's see. Sometimes they'll ask you only for the x coordinates, but in this case, they did not. They say find all relative extrema. So if they don't tell you just x coordinates, assume that's x and y coordinate. Okay? So if here we have a positive, that tells me the original function was increasing, all right? And then decreasing, and then increasing again. Yes? I don't think so.
It's the same thing.
It is equivalent, but I think you have to show that you know what F2 is.
Now you justify your answer.
I could be wrong, but I think you probably need to actually find the answer. So increasing and decreasing happens right here. We have a relative maximum. And then at 3, we go from decreasing to increasing, so we'll have a relative minimum. So if we find f of 2, I think it's still easier to plug into the factored form here. So you end up with 6 times 0 times negative 1, so you get 0. So you have the point 2, 0. So we would say f of x. Make sure you call it f of x. Or f. You can call it the function f. Do not say it. Have I let you guys know that it is like a mathematical cuss word?
Yeah.
We cannot say it. If you write it, I'm going to write what is it next to it and take off points. So f of x, yeah, I might have to come up with a new face for whenever we see that.
Like a mad face.
Yeah, an angry face, yeah.
You could do like
Yeah.
an angry face. That's like
Oh, no. I've made a major mistake. What did I do wrong? I did something wrong. Somebody tell me what I did wrong. I got to plug into the original, which I wrote like I was trying to do that, right? F of 2. But then I plugged into the derivative. Ugh. Alright, so let's back up here a second. And I usually on the AP test they give you ones easier than this, so let's just do. Anybody want to see if they can beat me? Alright, 38. And on your homework, I do not mind if you use your calculator for like just simple arithmetic. Don't use it to take the derivatives or anything like that. But our book is not super nice on the numbers it gives you. Sometimes you'll get bigger numbers that are going to take you a little while. I don't mind if you do this in the calculator, but don't use it to take derivatives and things of that nature. So if you find yourself using solve or derivative, then you're overstepping your bounds on what I want you to do with the calculator here. So f of x, then, we would say, has a relative maximum at 238. And then you have to put because, and your justification cannot be that the function changes from increasing to decreasing. You have to talk about the derivative here. So you can say f prime of x switches from positive to negative. So that takes care of our maximum. We have to do something similar for our minimum, which should happen at 3. So times 3 to the third minus 15 times 3 squared plus 36 times 3 plus 10. And I got 37. This is a relative minimum.
That's pretty tight. I think 37. Let's say,
Yeah, it's probably just like a little tiny dip. You know, this is a cubic, so it probably does like this. A little tiny dip like that. So it's like a baby minimum.
There's no absolute.
Right, there would be no absolute on this one. So we would also say f of x has a relative minimum at 337 because f prime of x switches from negative to positive. It is a lot of writing. Yeah. Usually this would be 3. You would get probably a point for setting the derivative, or a point for finding the derivative, or maybe setting it equal to 0 and finding critical points, one of those two. And then you get 1 for each one. It'd have to be the point and the explanation together. Yeah, so derivative we start from is going to be different. So like the derivative could be more complicated, but the yes, if they say justify, you have to do this. If it's multiple choice, you don't have to worry about it. There. Okay. All right. So this time, pretty much the same thing. Relative maximum, minimum. We got a trig function. Trig functions are typically going to be looked at only on an interval because trig, if you think of what sine and cosine look like, they repeat over and over and over again. So they have an infinite number of maximums and minimums usually. So they usually restrict it to a section of the unit circle that we're looking at. So
you can memorize the relative maximum minimum of sine and cosine. What if it was 2 sine?
you could, but the question's hardly ever going to be just sine or cosine. Like even in this case where it's sine plus cosine. Yeah. So.
But like, could you not memorize just plug it in to where it would be like if it's say here sine x cosine x, memorize it and you put in sine x and cosine x.
No. Because they'll have different signs at points. It might be the maximum of sine and a minimum, or like a not the maximum of cosine, so it's not the maximum overall. You got to do what we're going to get ready to do right now. All right, so derivative. Emerson, tell me what the derivative of this is. Everybody quiet so I can hear Emerson. All right, so cosine x minus sine x is our derivative. We need to set that equal to 0. How are we going to solve that?
So you have to think about 1/3 where does 2 factors? So it's going to be square root of 2.
All right, I'm hearing lots of different things. All right, so Jack, tell us what you were saying.
So
So at pi over 4, this is where we got root 2 over 2 and root 2 over 2. And so that's pi over 4. So that's one of our answers. Okay. 3 pi over 4 is right here. Are they the same there? One's negative, one's positive, so they're not equal to each other there. Over here, though, third quadrant, at 5 pi over 4, here they're both negative. Alright, so 3 pi over 4, and then over here, opposite sign, so they're not equal to each other. So we got 2 critical points on this interval. Yes, I don't know why I wrote down 3. I wrote 5 over here. Okay, so whenever we make our chart here, we've got 0 to pi over 4. And then we'll go to 2 pi. So on this one, this section right here is between 0 and pi over 4 on the unit circle. So pretty much the only option you have that's a unit circle value to test right there is pi over 6. And at pi over 6, we've got square root of 3 over 2, 1/2. So this one you're not going to make the chart for because your derivative doesn't have things that are multiplied together. You're just going to plug into the derivative. So if we find f prime of pi over 6, we'd have cosine of pi over 6 minus sine of pi over 6. And good. You do not care what that is. Don't spend time figuring out what that is. All we need to know is whether or not it's positive or negative. Would it be positive or negative?
It would be positive.
Positive. Square root of 3 is going to be bigger than 1, right? Yep. So we'll get a positive right there on that section. Okay. Then we are going to pick something between pi over 4 and 5 pi over 4. That is right here on the unit circle, right? I would pick either pi over 2 or pi because both of those are, in my opinion, easier to remember ones. So, like, let's do pi over 2. So, if we're doing f prime of pi over 2, we've got cosine of pi over 2 minus sine of pi over 2. So cosine of pi over 2 is 0. Sine is 1. We'll get negative 1, so we get a negative here on that section. And then it's probably going to be positive because it usually switches back and forth, but don't make that assumption because there are instances where it does not happen that way. So if we're looking here, I would probably pick 3 pi over 2. So if we do f prime of 3 pi over 2, then we're doing cosine of 3 pi over 2 minus sine of 3 pi over 2. What's cosine? This is your x value, which is going to be 0 here. And I've got minus sine is going to be negative 1. So that minus a negative becomes positive. And we get a positive 1 here. So we get a positive for that section. Yeah. Sometimes it will cause the eye twitch. Okay. All right. So this tells us that f of x would go from increasing to decreasing to increasing again. So at pi over 4, what do we have? Maximum or minimum? It's a relative maximum, and then relative minimum here. So let's just say this one also wants y coordinates. So we need to make sure we plug it back into the original. F of pi over 4 is sine of pi over 4. Is it plus? Yeah, plus cosine of pi over 4, which is going to be square root of 2 over 2, plus square root of 2 over 2, which gives you 2 square root of 2 over 2. 2's will cancel. We'll get square root of 2. So, f of x has a relative maximum at pi over 4 square root of 2 because f prime of x switches from positive to negative. You cannot say increasing and decreasing because, first of all, the derivative is not switching from increasing to decreasing. The derivative actually could be decreasing and positive. Positive means above the x-axis. But we also can't just talk about f of x and say, we can't say f of x has a relative maximum at pi over 4 square root of 2 because f switches from increasing to decreasing, because that's the definition of a maximum. So at the maximum, that's definitely going to happen, and it doesn't prove anything that you know why it has to happen. So you have to talk about the derivative. And the derivative, we're talking about it going from positive to negative. What you could do here, this would be totally optional, and I would discourage you from doing this because you might mess it up and then cause yourself to lose points. But you could say, which means f of x changes from increasing to decreasing. Yeah, so I do not suggest writing that, but if you did, it would be okay. It's not necessary. You are not required to include that, but you could. That is only our maximum. We got to do our minimum. These take forever.
So this would be on a true response topic from you.
Yes.
Multiple choice.
We'll see in a minute what's going to show what multiple choice will look like if you see this. So sine for your free response, you have 6 questions and you get an hour and a half. Six full questions, yeah. What you have been doing is basically, whenever you take your FRQ quiz, I give you 30 minutes for 2 questions. So it's timed the same. But on the AP exam, you will not have seen the whole entire first one to memorize the answers to it.
We're going to do practice the FRQ at the same time?
Yes.
We're going to do practice versions, right?
Yes.
I'm already doing practice.
You're already getting practice, but we will do
actual
more practice tests, release practice tests. And all of your testing quizzes, or not quizzes, all of your tests are coming from release questions pretty much anyway. A few of them I make up just because there's not enough out there. All right, so f of x, they don't. If they've released them, they don't use them again. AP is tight on security. Except for the year that we took it at home.
Y'all took it at home?
Yeah, the 2 years ago, COVID AP exam. It was 45 minutes long, and we took it at the house.
Oh my God.
And grading was lenient.
Grading was lenient?
Yes.
Like lenient.
had 2 students not even take it. They did not even take advantage of taking it from their home.
Really?
Yeah.
A photo math.
There honestly was nothing to keep you from photo math and stuff, but AP knew that, and they, it would have been difficult to photo math, a lot of it, but you could use your calculator to take any derivative they ask you to take.
Or you could have, someone, with, you pass it and, you.
What I think made it so unsecure, I do think it would have been hard to, look something up and cheat that would actually be helpful on the questions that they gave. But how did they not know that you didn't have, your older brother that was super good at math? Or that, the kids were not all in one room taking the same test? How do you know that's not the case? So.
Then we have Jack.
Yeah, how do we know somebody didn't just, pay... Yeah.
Oh, yeah, Jack could make a killing on that.
Pay Jack to take their test.
Yeah. Jack, how much did you charge? I got the money. You charge by the hour? It's 45 minutes. $100? I don't know. It'd be sus though because you get caught. That's it. Oh yeah, that's everything got. Everyone in the same class has the same exact answers for the same thing.
There's a movie about. Have any of you ever seen Stand and Deliver? Probably not. It's an old movie that calculus teachers love to show because there was a class of students. I think it was in LA, and this was early at the beginning of AP. I'm thinking early 70s because I think 1969 was the first year they gave the AP exam. And there was this teacher at that school that had really worked to build up the program. It was a low performing school, so it was he had a lot of kids from rough backgrounds, and so he worked with them, and he had they worked really hard, and they took the AP exam. And the whole class did something really strange on this one problem, but they were getting it right, and they made really good scores. He had almost all 4s and 5s. Everybody was passing. But the year before, I don't even know if the school had even taught AP calculus. It was a really low performing school. So AP pulled all their scores and accused them of cheating. So he fought it, and then they had to. The whole class had to retake the test again, a different test, and they had super high security, people from AP came and watched them take the test, and all the kids still did well on the test, and so anyway, the movie doesn't really explain exactly what exactly it was that.
Documentary?
Oh no, it's not a documentary. It's dramatized.
Oh.
It's not actually the people there. Yes, it is based on a true story. So it's one day. If we get time, we might watch it. It's a good movie. But. No.
Oh, I saw that with that blonde woman. Yeah, that's it.
I think my husband was watching that one night, and I watched it for 10 minutes and decided I didn't want to watch it anymore. Yeah.
It's what's the girl? She's that Cameron Diaz, is that her name? Yeah.
Okay. We're going to skip 3. All right. Let's look at number 4. Okay? Oh. The one that says f prime of x equals x plus 4x minus 3. So, this may be something they may do on the AP exam. They may, and actually I wrote this question and should say find all x coordinates. right. All right, so this particular problem, it should say find all x coordinates because you don't have the original function to go back to find the y coordinates, so it would be impossible for you to do that here. So this is the derivative. You don't have to take the derivative here. All you have to do is figure out whether the derivative is positive or negative. So you already have the derivative. You would set the numerator equal to 0 and the denominator equal to 0. So in the top, you would get x equals -4. You would get x equals 3. In the bottom, you're going to get x equals 0 and x equals 1. Technically, it's x minus 1 squared, but this means 1 shows up twice there. So these are your critical points. You do not put a plus or minus because it's x minus 1 squared equals 0. So you square root right here. So if you did put a plus or minus, it would go with that 0, which, you know, is just 0. And then you'd add the 1 over to the other side. If it was x squared minus 1, then you would have a plus or minus there. So we're going to put this on our chart. So we're going to have -4, 0, 1, 3. And then this one is one that's very helpful to use the chart. It's a 0, that's why. Okay, so we will list x plus 4, x minus 3, x, and x minus 1 squared. So those are all the pieces of our derivative. And then the last thing I always put is f prime of x. So if we're plugging in numbers here, something like -5 would give us a negative. But then anything above -4, it's like -3, it's going to be positive. So it's going to be positive for the rest of the ones here. Here we'd get negatives until we get to 3. Anything bigger than 3 will give you a positive. X will just have negatives whenever we plug in negatives, positives when we plug in positives. What will we get for this line, x minus 1 squared?
Positive.
Everything positive because it's squared. So then we're looking at, here we've got an odd number, so that's negative. Even, so it's positive. Odd would be negative. Odd again is negative, and then even is positive there. So here is our line that gives us our answers. So our critical points, what would we have it for? Maximum, minimum, neither one. I mean, sorry, -4. We'll have a relative minimum here. At 0, relative maximum, because we go from positive to negative. What about at -1? That's neither. Nothing happens there. Yeah, we have, so our derivative probably comes down and touches 0 and goes back up.
You like sketch a graph?
You can, and we will do a little bit of that, but not right now. But yes, you can sketch a graph. And then negative to positive here, that's going to give us another minimum. So negative to positive means decreasing to increasing.
That's the way I was thinking about sketching. It's like we were like,
yeah.
Negative to positive.
Okay, relative. So basically, when you write your answer, you're going to have so you'll say f of x has a relative minimum at, in this case, you only got to give the x-coordinate, x equals -4 and x equals 3. Because, and so this is always your reason for relative minimums when you're using this first derivative test. F prime of x switches from negative to positive. If you put it, I think it would be okay, but I think it's understood here where that's okay. Yeah, I think it's understood that you're talking about that point of a relative minimum. But if you said, because it switches from negative to positive at -4 and 3, I think that would definitely be okay, but I don't think you have to. So whenever we see the derivative on our chart, so we're thinking about this highlighted part, when it goes from negative to positive, that's going to be a relative minimum. And if our derivative goes from positive to negative, then that's going to be a relative maximum. The reason that is because if we think of adding like a little line in here that is our f of x, negative tells us that we're decreasing. And then we switch to increasing. And then we switch back to decreasing, keep decreasing here, and then we increase again. Right. What usually happens there is you have like a point of inflection, which we'll talk about later, or maybe a cusp in the graph, or a vertical asymptote possibly. It just depends on the problem. But it does happen occasionally. Yes?
So if you have the original equation, plug those back in
to get the y coordinates, yes. Because we don't have that here, they can't ask us for it, so they only ask for x coordinates. And then we should also, I guess, say f of x has a relative maximum at x equals 0 because f prime of x switches from positive to negative.
So we decide between maximum by the sign of the interval before. So with a relative maximum positive before,
not necessarily the sign before. Well, yeah. Yes, but it has to change also. So it could, like at 1, that's not going to be a minimum.
no change.
Right. No change means neither one. But think about the one before it, because if you're going from decreasing to increasing, that gives you minimum. So there has to be a change, and if you want to think of it like that, first one's negative, that gives you minimum. First one's positive, it gives you maximum. That is accurate as long as there's a change. Okay, questions on that one? All right, so here is what a multiple choice will look like, and this one would be calculator active. So I'm going to grab the calculator real quick. Okay, now, they'll do something like this to you on the exam. This is not the original function. It is the derivative. So when you type it into your y equals on your calculator, this is the derivative. And we can graph it. Here, my window might be strange. I'm just going to go back. I'm going to do window. Actually, I'm going to do F2, zoom, 6, just standard zoom. See what I've got here. That looks like it's probably, this is a cubic, so that looks probably like it's right. So, this is not F. They are not going to give you a function like this and ask you about what you're looking at. So, do you know how to do that? Try it. I just want to see if you can. Here, this function has one maximum and one minimum, correct? It is not the answer that there's one maximum and one minimum, because this is the derivative. Okay? The question is asking you about f, not the function you're looking at. Okay, so I'm going to just say this is if I think about making a line here, I need to think about not whether or not this function has a maximum or minimum, but whether or not this function is positive or negative. So my y-intercepts, let's see. Yeah. Well, yes, except for, Daniel, like when you take the derivative of this, there could be a plus 10 or a minus 7 or a plus 32 on the end, which doesn't change the derivative, so it will not. Right, it wouldn't change. It wouldn't change the relative. Yeah. You could, but do it this way, because there'll be ways that they'll give it to you. I'm impressed though, because you just took the integral of that without being taught how to take the integral. So, good job. All right, so it looks like it's about -2 and about 1. Since it doesn't ask you for specific points, it's not really important here where it hits that x-axis. So my derivative from -infinity up until this point right here, is it positive or negative? Is negative because it's below the x-axis, right? Below the x-axis is negative. All right, what about between -2 and 1? It is positive. What about from 1 to infinity? Also positive. So, what do we have here as far as relative maximum minimums go?
We have a relative minimum and just a max, or is it a max?
No maximum here because it does not change. So we have one relative minimum, no relative maximum. So B would be our answer.
How did you plug into the calculator? And then just look at it?
Sometimes they'll give you something like this and make it calculator active. Sometimes they might give you the graph and not the equation and ask you the same question, in which case it wouldn't be calculator active. So when you look at this graph, you don't want to think about increasing and decreasing and where that graph has maximums, but you want to think about because that is the derivative, we want to know whether it's positive or negative. So above the x-axis or below the x-axis. Oh. So it's below the x-axis here, and then it switches to above the x-axis here, which gives you, at that x-coordinate, x equals 2, you're going to have a relative minimum. No, we're just doing it from the graph instead of doing it from, yeah. No. If you find yourself answering the question about the graph you're looking at, you're probably doing something wrong on these problems. Because they will not just give you a picture that looks like this and say, how many maximums and minimums does it have? Because that is, yeah, Math 1 could figure that out, right? So if they give you a picture, they're probably not asking you the question about the picture that you have. All right, so let's see. Is this our? We don't have time for it. Okay. Last one. We got time for this. Okay. All right, so Function is given by this. At what values of x does this have a relative maximum? This one is not calculator active. So we need derivative. What have we got to use to take that derivative? Product.
And then chain rule.
It's got a little bit of a chain rule in it. So we'll have e to negative x times the derivative of 2x plus 2. Make sure you put parentheses around that 2x plus 2. I think I took off points on Jax for that one because he did not have parentheses around his on one of his FRQs.
And then you plus.
They've got to be there. Because if they're not there, if you write it like this, it is understood that you're only multiplying e to the negative x times the 2x and not the 2x plus 2. I know you knew what was happening there, but mathematically you did not write it down correctly, so you lost points on that. So put those parentheses. He was mathematically. Yeah. All right. So we have x squared plus 2x times the derivative of e to the negative x. What is that? E to the negative x times negative 1, so we get negative e to the negative x.
I wonder if Amish do calculus.
I'm sure that they can. Alright, so e to the negative x. If we you don't necessarily have to simplify this, but it's going to make it easier to do the next parts if you do simplify it. So if we factor out an e to the negative x, we'll have 2x plus 2. And then this negative right here, since it's still there, we need to distribute that. So we'd have minus x squared minus 2x. Plus 2. And I would probably write it like this. 2 minus x squared over e to the x. And if you want to, you could even no, you can't. Never mind, you can't factor that. Don't factor that. If it was a 1, I was going to do like 2 minus x, 2 plus x, but that is not correct because 2 is not a perfect square. So if you did that, you'd have to do like square root of 2 minus x. That just makes it more complicated. So top equal to 0, bottom equal to 0. So 2 minus x squared equals 0. 2 equals x squared. Square root both sides. You get plus or minus square root of 2 equals x, 0. That's the only one because e to the x is never going to equal 0. E to the x is always positive. So, you got negative square root of 2 and positive square root of 2. So e to the x is always positive, right? So you could leave it off of the chart or include it. And then you got 2 minus x squared. So 2 minus, let's say like negative 2 squared would be 2 minus 4, which would give you a negative. Put 0 here, you get a positive. If you plug in something like positive 2, you get a negative, a negative right here. So your derivative goes from negative, positive, incorrectly. Alright, negative. And so we're looking for how many, or at what value of x do we have a relative maximum? So which one would be the maximum here? The positive square root of 2, because our derivative goes from positive right here to negative right here. So positive square root of 2 only would be our answer for that. Okay, I think I've got homework all messed up. Because I had something different on this, so let me look and see what I really want you to do. Is 307. So, yes. Let's see.
Can I get something for sure that I will be late for the rest of the room?
You'll have a match today, don't you?
Oh, but we're leaving at like 4.
Okay. All right. Let's see. Do I want you to do this instead of 21, 25, 27, 33, 39. Let's do this. Don't do 41. I want you to do 45. Alright. Okay, so I had the homework wrong last night, so Jack and Daniel have already done some of these, but not all of them. So, all I want you to do here is find relative extremement and justify your answers. The instructions are going to say to tell whether it's increasing or decreasing and that stuff there. But this will be your assignment that is due on Monday whenever we come back. Yes. Yes. You don't have any paper? There's some up here if you need it, Daniel. If you need to tap into the paper welfare system of Mrs. Hyatt's room, you may. That's what it's there for.